In this lesson, we will divide a polynomial using synthetic division, then rewrite the answer in division algorithm form. Division algorithm. Let f of x and g of x be polynomials with g of x of lower degree than f of x and g of x of 1 degree or more. There exists unique polynomials q of x and r of x such that f of x equals gx times q of x plus r of x, where either r of x equals 0 or the degree of r of x is less than the degree of g of x. Ooh, wow, that was a mouthful. Okay, so let's put that in plain English. All right, so in plain English, I'm going to use this example here. So g of x we're going to refer to as the divisor. Remember, even if you're going to use the long division method or synthetic, whatever number is on the outside is your divisor. Whether you're using whichever method, whatever number is on top is your quotient. And let's call that quotient to stand for q of x. Whatever is under this symbol is called your dividend. And let's call that f of x. And whenever you have a number left over, that is called your remainder. Let's call that r of x. So all it's saying here is the divisor times the quotient plus the numerator equals the polynomial itself, the function itself. So again, it's saying the divisor times the quotient plus the numerator equals the polynomial itself. Okay, so another way to think of it, a little simple division problem like this one, the divisor times the quotient equals the dividend. So you can write it as 3 times 5, it equals 15. Let's write this example in division algorithm form. So first I'm going to have the divisor, which is x plus 1 in parentheses times, in parentheses, the quotient x plus 2. Now all I need is to add the remainder. The remainder is 3, and then you write plus 3. And there you have it. That is division algorithm form. Nothing complicated at all about it. The most work will involve first solving the long division or synthetic division. Once you do that, you're simply writing it in this division algorithm form. And there you have it. So let's do a problem from start to finish, and then we're going to write or express our answer in division algorithm form. So we're given a polynomial or function of f of x equals 3x cubed plus x squared plus x minus 5, and k equals -1. When they tell you k equals something, k is your divisor. So on the outside, we're going to have -1. And then we're going to have underneath our symbols our dividend. Now, let's go ahead and use synthetic division since it's usually so much quicker and it's one that's preferred by most students. So if we're going to use synthetic division, recall we're going to need the coefficients of all the terms. So the coefficient of the first term here is 3. The coefficient of the next term is 1. The next coefficient is also a 1. And then the last is a -5. So let's go ahead and set it up so we can begin to perform the synthetic division process. So recall the process. I'm going to first bring down a 3, multiply that with -1 to get -3. Combine those and bring down a -2. Multiply that with -1 to get +2. Combine those together and bring down a 3. Multiply that with -1 to get -3. Bring down a -8. So here we have an answer that has a remainder. So now we want to put it in division algorithm form. Recall that synthetic division only gives you the coefficients. We have to go in and put our variables in, and it always begin 1 degree less than the original polynomial. So this polynomial begins with a 3. So that means if we go 1 degree less, we're going to start it with squared. So 3x squared minus 2x plus 3, and we have a remainder of -8. In terms of division or algorithm form, we have to first write our divisor. So let's put our divisor in. If -1 is out here, recall, when you put it back into x minus k form, it is going to be x plus 1, the very opposite. So we have x plus 1 as our divisor. Here is our quotient, so we're going to have that also in parentheses behind it with a -8 as your remainder behind it. And there you have it. This is the division algorithm form. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.